All right, in the final video, I want to do a few questions that are sort of like extensions of what we've been doing. So you've got problems on the back that maybe aren't really quadratic, 27 through 29. They're not straight quadratic problems, but you're going to be able to solve them using quadratic techniques. You should be able to do number 27 for the most part. It's basically, I could have asked you that on the last test. Actually, I'll go ahead and do it. I'm going to do all three of these. So here's 27. Here's 28. Okay. And then 29. Okay. All right. So this is degree 4. It's not a quadratic, but we're going to be able to use quadratic techniques. The first thing I would recommend you do is try factoring. Okay. And it'll break down into x squared and x squared, 4 and 1. If I made the 4 negative and the 1 positive, that would work. Now at this point, you could break down the x squared minus 4 more, but you couldn't break down the x squared plus 1, yet I'm still expecting you get all the solutions. I think the best thing to do is to go ahead and set each of those factors equal to 0, because now you know about the square root method, and that would be a good way to handle these. Just add 4 to both sides. You'd get x squared equals 4. Here, you'd subtract 1 from both sides. Get x squared equal negative 1. Now come in and do the square root of both sides, making sure you get the plus or minus. So this would be square root of x squared equals plus or minus the square root of 4. Over here, the square root of x squared equals plus or minus the square root of negative 1. All right, well, square root of negative 1 is I. So 2 of the solutions are plus or minus I. The other 2 are plus or minus 2. Okay. And so see, if you had tried to solve this by factoring, when you got to the x squared plus 1, you weren't going to be able to factor that. And so you might be tempted to say you don't get any solutions from that, but you really do. You just get 2 imaginary solutions. So you got 4 answers. Here they are. You don't have to write them separate like this. You can just circle these. But I just am emphasizing that it was degree 4 and you wound up with 4 answers. Okay, this one turns into something very similar to 27. This one is actually a radical equation. And this one is a rational equation. Okay, so I'm looking at 28 and I'm thinking how I see a y that's trapped under the radical, and I also have the y on that left-hand side. So I really need to undo the square root. And so we've used this a lot. We've used square roots to undo squaring. It's the same idea except for in the reverse order. I'm going to come in here. Let me do it on a separate line though, so we always have the original sitting there. I'm going to come in and I'm going to square both sides. I'm doing that to undo the square root. So over here I have just 3y plus 4. But if I do that to one side, I do that to the other to get the y squared. Right now, there's a bit of a danger here that you need to be aware of. The original problem in this right here aren't really equivalent. They don't necessarily have the same answers. When you square both sides, you got to make a mental note to check your work, because you might introduce things that work on the y squared equal 3y plus 4, but they don't work in the original. There's nothing wrong with your process. That's just part of the process. So you must check, okay? That's what that little asterisk means. So what you're going to do, though, for a moment is just to go and continue from there. So you'd subtract 3y, subtract 4. There is a middle term, so you're not going to use the square root method. You're going to try factoring. Okay, and it works well. Notice it's the same type of thing you got over here because it was really the same situation for the most part. You set those factors equal to 0. And you wind up with 2 answers, y equals 4 or y equals negative 1. But you squared both sides, so you have to make that mental note. You must check answers. So what I mean by that is you're going to take that original problem. Let me write it twice here. before you did anything to it, take that original problem and then plug in 4 everywhere there is a y and plug in -1 everywhere there is a y. Keep everything else the same. So I'm plugging in the -1 on one of these. And what I'm doing is I'm checking, does it really work? Does this really work? Okay. Now these could both work. They could both not work, or one could work and one might not. You just don't know. So you have to just try them. So this would be 12 plus 4, which is 16. The principal square root of 16 is 4. And 4 does equal 4 for sure. So I'm going to go ahead and put a circle around this guy. It works. Now, they both could work or they both could not work, or one could work and one doesn't. See what happens here. 3 times -1 would be -3. When I add 4, I'm going to get +1. When I take the positive square root of 1, I get 1. I don't get -1. Don't get -1. That one doesn't really check. This one right here needs to be ruled out. So my only answer to the original question is 4. See, 4 and -1 would work here, both of them, but in the original problem, only the 4 would work. Okay, and the reason for that will be easier to explain once you've had a little work with domain and range. It has to do with the fact that it has to do with domain. Okay, I'll just leave it at that. I'm trying to squeeze that up a little bit. Okay, there we go. All right, so the only new thing is you had to think about how to get rid of the square root. So that idea of squaring both sides. And then the other thing is that you must check your answers. But this whole middle part right here is just what we've been doing. Okay? All right, now something like that happens on a rational equation. All right, it starts out looking like this. Okay, let me blow that up just a little bit. All right, and I've got fractions, which I'd prefer not having. So I'm going to use a technique. I actually taught this in math, this technique in my Math 98 recently. I'm going to clear the fractions. Oh my gosh. Okay, so I'm going to come in and I'm going to multiply through on both sides by x squared. I picked x squared because it's the least common denominator. It's the thing I could multiply by that would knock out those denominators, okay? So I'm going to multiply through by that on both sides. I usually don't show this step right here. I usually just show this one. So I'm going to take x squared times the 1. I'm going to take the x squared times the 6 over x. Keep that x squared up high because it really is on the same level as the 6. And then x squared times the 16 over x squared. You know, that has to get distributed, doesn't it, to all of those. And then x squared times 0 is still 0. Okay, so what I wind up with here is x squared. In the middle, remember back in section 4.1, I think it was, how we could knock out that x is common, so we could knock out that x, and we would just have 6x here, x squared on top, x squared on the bottom. We can knock that out. We'll just have minus 16 equals 0. Okay, so this one is kind of like number 28 in that the original problem, and then now right there, they're not quite equivalent. You could have answers that work here that don't work in the original, but for a different reason. See how the original problem has denominators? You're going to need to check your answers at the end to make sure they don't make those denominators equal to 0, because you can't divide by 0. Okay, but you don't need to do that right now, except I want you to remember to check your answers. Then you just go through the process. So you should try factoring. Most of these are going to factor. If they didn't, we would use the quadratic formula. That one factors into x minus 8 and x plus 2. Looks like I'm going to get 2 solutions. Looks like I'm going to get x equals 8 or x equals negative 2. And so you must check to be sure these don't make the denominator, I should say any denominator 0, okay? If it did, I'd have division by 0, which would be undefined. So when you look at this, 1 minus 6 over x minus 16 over x squared, the only thing that would make the denominator 0 would be a 0. It would be a 0 itself. So basically, I know that as long as my x is not 0, these should be the solutions. They should work if I did all my factoring and arithmetic correct. So I'm not really checking whether I did my factoring correct. I'm just saying, assuming all of this is correct, so I'm pretty sure I did all that right, then those will be my answers, because they will not, if I were to plug them in for x, they would not make a denominator 0. Okay? All right, and then I want to do the number 30. So I'm working that whole last page for you. Hopefully you tried it already on your own as well. All right, and then the other thing I wanted to look at is an application. Now you got to fix something for me, because it started out as a rocket, and then on part B it turned into a ball. So just change that to a rocket. All right, so we got this rocket, we're shooting it up, and it's going to fall back down. So starting at the ground, goes up, and then comes back down. The distance in feet above the ground in t seconds is given by this model. Sometimes they use S for the distance. This one used a D, okay? So here's the model. Now, if this is the path of the rocket, this is what the rocket is actually doing, but if I were to think about the distance above the ground here, which is like the height of the rocket, and this were the time, then, I could take measurements, after 1 second, after 2 seconds, after 3 seconds. So it's going to go up, and it's going to reach whatever that highest point is. Then it's going to come back down. Nice symmetric U shape. Okay. And what I want you to think about is on question A, it says, at what time will the rocket hit the ground? So think, when is D equal to 0? So you need to solve, when is 16t squared plus 157t equal to 0? That's the ground, hitting the ground. Okay, so we'll finish that one, but let's go ahead and set up part B. All right, on part B, it says, at what time or times will the ball be 210 feet from the ground? You should still be thinking that that's telling you that D is 210. So on that one, you're going to have negative 16t squared plus 157t equals 210. Okay. All right, so I'm going to work out A all the way, and I'm going to get you started on part B, but let you finish it, and then you can check your answers on the answers that I posted. A, I thought I would work out because it's a little different. Since there's a t squared and then a t, you could factor out a t. And you may be able to factor out a number, but I just didn't try. All right. And so then I've got two factors multiplied and equal to 0. So either t equals 0 or negative 16t plus 157 is going to equal 0. By the way, when you're using t's, it really helps to make the tail of the t kind of curve to the right so it doesn't look like a plus sign. So I'm going to finish that negative 16t plus 157. I'm going to subtract the 157. Then I've got to divide by the negative 16. Okay, so I'm going to do that. Where's my calculator? All right, let's see what happens. Sorry, I got to get into my phone real quick. Get into that calculator. I'm going to take that 157 divided by 16. I already know it's positive. And that turns out to be about, and let's see, that one said up at the very top, round your answer to the nearest tenth. So that turns out to be around 9.8. So that's t being 9.8. That's 9.8 seconds. So it's saying it's going to take 9.88 seconds for that rocket to come back to the ground. So what the 0 was this starting point. The 9.8 is really what I want for part A. So that would be your only answer. Okay. Right, and then we're just going to get started on B, and I'm going to let you finish that up. So your setup should look like that. Then what you're going to do is subtract the 210. You could add the 16t squared and subtract the 157 to the other side, but anyway, you're going to get a 0 on one side. And then just use the quadratic formula with your A, your B, and your C. And remember, you don't have to simplify the radical when you get there. You just do the square root on your calculator. So you should come in and you should do all that business. And on that one, it's asking, at what time or times will the ball be 210 feet from the ground? It's kind of like this. Imagining being 210 feet up. Okay. Where is it going to hit it on the way up? Where is it going to hit it on the way down? That's why you're getting two answers. Okay. All right, so I think you can finish that up and then check your answer on the answer sheet. So I'm going to get this thing